events are mutually exclusive if they cannot occur at the same time. So notice I said they are mutually exclusive if they cannot occur at the same time. So what you're trying to figure out in the problems that we're looking at first is if the two events that we talk about, if they can both happen or if they can't both happen. Okay? Is it possible that you could have brown hair and red hair at the same time?
Yes.
Yes.
Yeah. It's called Auburn. Red highlights.
You probably could.
It's called Auburn.
So yes, you can, which means it's not mutually exclusive. Okay? Can you have a blue and green eyes at the same time?
Yes. Is that brown and green?
Yes, you can. That means it's not mutually exclusive. Okay? Can you come to school on time and be late at the same time?
Yes. No.
Yes, you
When you
can.
get here.
Yes, because you can get here on time, but you can't
You
walk
get
in
here
the
at 8
classroom.
o'clock, get to your class.
Okay, I did not ask.
He's talking about getting to
I
the
did not
class.
ask when you arrive to class. I said, can you be at school on time and be late?
What if
No,
it's like-
you can't. You're either here on time or you're not.
What if it's like 7:40?
You're either here on time or you're not. So those two events are mutually exclusive. Okay? They can't happen at the same time. They can't happen at the same time. So they are mutually exclusive. Okay. Can you be a football player and a basketball player?
Yes.
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 Yes, you can.
Who said
So is that mutually exclusive or not?
no?
Not mutually exclusive. Okay, so if the thing can happen, it's not mutually exclusive. Okay, so first question up here. A junior winning the election or a senior winning the president of the student body election? Can the junior and the senior both win at the same time?
No.
So you said no, so that means it is mutually exclusive. So we're going to say yes, and we're going to abbreviate mutually exclusive as ME. You can write mutually exclusive if you want to.
Me.
Wait, I don't like the question.
Red's on innocent.
So, in number 2, drawing an ace or a club from a standard deck of cards. So, we've already determined that there's one of these in everything. There are clubs, so an ace and a club. Can you get an ace and a club at the same time?
Yeah.
You can.
So there's like.
So that means it mutually exclusive or not?
I don't understand. Because are you not drawing?
It doesn't matter if it says or.
I
Okay?
I'm sorry.
So when you look at it, you draw one card and you try to figure out, can that card be those two things at the same time or not? Okay? The card can be an ace and a club at the same time because there are ace of clubs.
Oh, I thought
Okay?
you can draw an ace and a club.
Okay? But because I can draw a card that has an ace and a club on it at the same time, that makes it mutually exclusive. Now, if it said, can the card be a diamond and a heart?
No.
The answer is no, so it would be mutually exclusive. But this one is not mutually exclusive.
Basically, it's
Okay.
opposite.
What is
Yes.
mutually exclusive?
Okay, number 3. Getting a sum of 6 or 7 when 2 dice are rolled.
No.
So if I roll 2 dice
No.
and I look at those two numbers, can it be a 6 and a 7 at the same time?
Yes.
It
No,
could-
it's like some.
You know,
What about
you could roll a 6 and have a 1.
15-sided dice?
Yes.
So yeah.
Okay, it's asking for the sum of the two. Okay? When I look at them, it's either a 3 and a 3 or a 6 and a 1. It's either a sum of 6 or a sum of 7 or not. Okay? It can't happen at the same time, so it is mutually exclusive. So next question says that we want to figure out the probability of rolling a sum of 6 or a sum of 7. So now we want to figure out the probability. We already know it's mutually exclusive, that you can't get that at the same time. But we want to figure out the probability. So what we're going to do on this problem is we're going to write out the possibilities. Okay? So how can I get a 6 if I roll?
3, 3,
Okay? A 3 and a 3.
2, 4,
2 and 4.
1, 5.
What about 4 and 2?
Yes.
Okay. I heard 1 and 5.
You have to switch to
5 and 1.
5 and 1. That's the only way to get a 6, right?
We're just irregular, yeah.
Okay.
Are these numbers ever going to be like 100?
Okay, let's say we want to get a 7. 4 and 3 I heard. I heard 1 and 6.
6 and 1.
6 and 1. 3 and 4. I heard 5 and 2.
3 and 4.
2 and 5. Any other choices? Okay, so none of those overlap, right? Okay, there's no overlap. That means that it's mutually exclusive. If there's no overlap, it's mutually exclusive.
What does it look like when it overlaps?
Okay, so what's the probability that you get a sum of 6?
5.
5 out of, how many possibilities do we have?
36.
We wrote out the choices the other day on the back of that note paper. It was a big old table.
Oh, yeah.
It's 36. Okay. What is the probability that you get a sum of 7? 6 out of 36.
Wait. This is.
And is, what's the probability that you roll a sum of 6 or 7? Okay? If I find the probability of rolling a 6 and I find the probability of rolling a 7, if I want to find the probability of rolling a sum of 6 or 7, I just add it together. I just put it together. So what's the probability going to be? Okay? That only happens if the events are mutually exclusive. If the events are not mutually exclusive, something else happens. Questions? Okay, suppose you roll a die. You're rolling a number greater than 2 or an even number. Rolling a number greater than 2 and then rolling an even number. Are those two events mutually exclusive or not?
No, they're not exclusive.
So when I roll a 2 or a number greater than 2, it is possible for me to get an even number, right? They can happen together.
Yes.
So it is not mutually exclusive. Okay? Because it's not mutually exclusive, the probability is not quite as simple as it was in the last one. I can't just add the two probabilities together. Okay? All right. So this is a formula. I'll explain the formula. You do not necessarily have to use the formula. Okay, just hang on. Okay. Think about the numbers greater than 2. When you're rolling a die, tell me the numbers greater than 2. 3, 4, 5, and 6. Okay? Tell me numbers that are even numbers.
4 and 6.
It just says, okay, it says greater than 2. That's the purple. And then it says even. So just tell me even numbers.
4 and 6.
2, 4, and 6.
Why would you do 2?
Okay?
You said it was
Listen, I'm trying to find the probability of just greater than 2, and then I'm finding the probability of an even number. I'm not putting the two together yet. Okay? Do you agree with the numbers I have there?
Yeah.
Okay. Now, because the problem says or, because I'm trying to find the probability of one or the other, I need to include any number that is either greater than 2 or is also even. Okay? I can't just add the probabilities together like I did on the last one, because if I did, I would get 7 over 6. Because there's 4 greater than 2 and 3 evens. Okay? That doesn't even make sense. Okay? What I really want to do is just think about the numbers that fit the situation and then divide it by 6. So 3 is greater, 4 is greater, 5 is greater, 6 is greater. I've already included 4 and 6. I don't want to add it again. But I haven't included the 2 yet. So how many numbers are either greater than 2 or even?
5.
5 of them. So the probability of getting one or the other is 5 over, not 36, 6. Because it's just one die. Now, I can use that formula up there if I want to. The probability of greater than 2, this A is going to be greater than 2, B is going to be even. Okay? Probability of greater than 2 is 4 over 6. Probability of even is 3 over 6. And if I subtract, this little part right here means and. That means the part where they're both greater than 2 and even. How many are greater than 2 and even? Of those choices, how many are greater than 2 and even? 2 of them, 4 and 6. Because 4 and 6 are greater and, yes, that's what and means. And means both. Okay, so I have to subtract off 2 out of 6. And if I do that, that's 7 minus 2, which is 5. That's another way to get 5 over 6. I think the other way is easier. But if you don't like really just kind of thinking about it, if you want to use the formula, you can use the formula. Okay? So let's look at another one. Number 2. So we're back to the cards again. Okay? Changing our minds. We're not talking about die or dice anymore. So we're looking at cards. It says drawing an ace or a club. We've already figured out that you can have an ace or a club at the same time. So it's not mutually exclusive. Okay? So if I want to try to find the probability of doing one or the other, I have to think about when it occurs together and when it doesn't. Okay, so think about the cards here. How many aces do we have? 4. So there's 4 aces. How many clubs do we have?
13.
13. Okay, so we got 13 clubs. We have 4 aces. All right. When I say that there's 13 clubs, have I already included the ace that was in the 4? One of them I've already included, right? So my answer is not 17 over 52 because one card is included in both of these because there is an ace of clubs. So the ace of clubs is included in the 4, but it's also included in the clubs. Okay? So I got to get rid of that one that I'm including twice. So what's my probability going to be? 16 over what?
52.
Now, if I use the formula, it would be, and that's supposed to be and, not and. Probability of drawing an ace would be 4 over 52. Probability of drawing a club would be 13 over 52. Minus probability of drawing an ace and a club. We've already concluded that's one of them because one card is an ace of clubs. And we get the same thing. So you can either think about it or use the formula, either way. All right. That's an equals. Okay, last says, the complement of an event would be all the outcomes not in the event. It's probability of not A. So, for example, if I said the probability that it is going to rain outside is 90%, what was the probability that it's not going to rain? 10%. So you're just subtracting 100% or subtracting from 1. If I tell you the probability of doing something is 1/3, what's the probability of not doing that thing? 2/3. You just subtract it from 1. Okay? Alright, so probability of not drawing a club. So what's the probability that you do draw a club? How many clubs do we have? 13 over 52. So not drawing a club, you can either do 1 minus 13 over 52, or you could do 52 minus 13, figure out how many cards there are, and divide it by 52. 39 over 52? Okay, next one says probability of not rolling a 6. What is the probability that you don't roll a 6? Okay.
I got that wrong. Anna said hi.